We will present the case study on an LCA, comparison of chicken manure and rapeseed for electricity generation. For this assignment, we will use Kiem LCA program in order to compare energy generation using chicken manure and that of rapeseed oil, and using the greenhouse gas emissions to find the global warming potential for both processes. An LCA is based on the idea of life cycle thinking that considers each stage in the life cycle of a process from cradle to grave as opposed to gate within one stage. The one process considered for comparison is rapeseed growth, the production of rapeseed oil, and then combustion. The second process is considering the two functions of chicken manure, its treatment combined with energy generation. We will now look into more detail at both processes, the boundaries, and then do a comparison. Now we will analyze the rapeseed chain process. Starting with the 5 inputs on the left that goes into production of rapeseed to transportation that goes to the drying of the rapeseed. Note that we use the lorry truck as a form of transport. There is electricity inputs for drying, storage, and cold pressing into rapeseed oil. Fuel input into electricity production from co-firing and not for electricity production from combustion. Electricity formation and transport to the consumer from both types of electricity production. Only the direct inputs are considered within the system boundaries of rapeseed oil. Transport by lorry, the CO2 emissions only per kilometer, and not any production inputs. Fertilizer inputs are taken into account, but not the production of fertilizer. Energy for treatment and incineration is used, but again not the production of facilities. The allocation decisions of rapeseed oil. The default allocation used in the chain with calculations on physical partitioning. Now we move on to the process of chicken manure. This is the chain that will be discussed in more detail. It shows that original chicken manure is being transported across 150 kilometers by lorry trucks. The drying process receives heat from natural gas as an input. This process shows the combustion of manure. That process, electricity that gets transported to consumer. We assume chicken manure as waste as opposed to a good because the purpose of chicken farming is not for the manure but for eggs and meat, so the manure is a byproduct. We do not consider the biogenic emissions, as we only take into account the carbon emissions from fossil fuels and not stored by carbon sequestration. At the drying process, the before considered waste is now turned into a good, on the basis that only after the manure is treated, it can be considered a good. Thus, we choose the allocation of the chicken manure, also done by partitioning on a physical level, like that of the rapeseed allocation. This is the process table for chicken manure and the data that we used. Some explanation is given as to how certain flows are calculated. Throughout the comparatives LCA, we assumed that chicken manure is a waste initially and only turns into a good at a later stage. The resulting graph does not only consider CO2, but also methane and other contributing emissions. Rapeseed oil, the blue bar, depicts a much higher global warming potential than the green bar, which is chicken manure. We will now compare the processes of rapeseed and chicken manure electricity generation. It is clear that there are far more processes and inputs involved in rapeseed, and therefore also more emissions. Also, as we initially only considered the impacts of chicken manure after the drying of the waste, emissions from earlier stages in chicken manure chain were not included. However, specifically the drying process makes a difference in terms of methane emissions. This methane is ignored in our calculations as it is considered a waste. Furthermore, all the emissions before the storage stage is neglected when the manure is still a waste. To compare, we also considered the difference if the chicken manure was a good from the start. The global warming potential would be higher as the transportation contribution and the storage of the chicken manure would be included. Especially during the drying process, a lot more methane is emitted. As methane has a strong global warming potential, the impact of the chicken manure chain becomes bigger if we consider the chicken manure as a good in earlier stages already. To conclude, we notice that the outcome of an LCA depends on the boundaries we set and the assumptions we make. Regarding this specific case, chicken manure has less emissions irregardless of whether or not it was considered a good to begin with or later on in the cycle. Our recommendation for improvement is to investigate for measures to capture methane emitted in the storage phase or compare it to outcome to biogas production. Thank you.